Welcome to our exploration of one of the most fascinating topics in space science, water on the moon. You might think of the moon as a barren, dusty landscape, but recent discoveries have revealed that it holds secrets that could change our understanding of lunar exploration and even the future of human life beyond Earth. In this video, we'll dive into some little-known facts about water on the moon, uncovering its significance and the implications for future missions. We'll start by discussing how scientists have detected water ice in permanently shadowed craters where sunlight never reaches. This ice could be a game changer for astronauts, providing a vital resource for drinking water and even rocket fuel. Imagine the possibilities if we could harness this water for long-term lunar bases. Next, we'll explore the various forms of water found on the moon, from ice to vapor, and how these discoveries challenge our previous notions of the lunar environment. We'll also touch on the ongoing missions and research efforts aimed at understanding the distribution and accessibility of this precious resource. So, whether you're a space enthusiast or just curious about what lies beyond our planet, stick around. By the end of this video, you'll have a deeper appreciation for the moon's hidden treasures and their potential to support future exploration. Let's embark on this exciting journey together and uncover the mysteries of lunar water. One of the most intriguing discoveries about water on the moon is the existence of water ice in permanently shadowed craters, such as Shackleton Crater. These craters are located at the lunar poles and never receive direct sunlight, creating an incredibly cold environment where temperatures can plummet to around -250 degrees Fahrenheit. This extreme cold allows water ice to remain stable and preserved for billions of years, making these locations crucial for future lunar exploration. The implications of finding water ice in these craters are monumental. For astronauts planning to establish a long-term presence on the moon, having access to water is essential. Not only can it be used for drinking and hygiene, but it can also be split into hydrogen and oxygen, providing fuel for rockets and life support systems. This means that lunar bases could potentially become self-sustaining, reducing the need to transport resources from Earth. NASA's Lunar Reconnaissance Orbiter has played a pivotal role in identifying these shadowed craters. Equipped with advanced imaging technology, the orbiter has mapped the lunar surface in unprecedented detail, revealing the locations of these ice deposits. By studying these areas, scientists can better understand the moon's geology and climate, paving the way for future missions aimed at utilizing these resources. In summary, the discovery of water ice in permanently shadowed craters not only enhances our understanding of the moon, but also opens up exciting possibilities for human exploration and habitation. In addition to the water ice found in permanently shadowed craters, scientists have discovered the presence of water molecules on the moon's surface itself. Instruments like the Moon Mineralogy Mapper, which was on board India's Chandrayaan-1 mission, played a crucial role in detecting these molecules. By analyzing the reflected sunlight from the lunar surface, the mapper identified spectral signatures indicative of hydroxyl, OH, and water, H2O molecules, revealing that water is more widespread than previously thought. These findings are significant for understanding lunar geology. The presence of water molecules suggests that the moon's surface is not as dry and lifeless as once believed. Instead, it indicates a dynamic environment where water can be formed through chemical reactions, possibly involving solar wind and the lunar regolith. This challenges our previous assumptions about the moon's history and its potential for supporting life, even in microbial forms. Moreover, the implications for future missions are exciting. Water molecules on the surface could be harvested and utilized by astronauts for various purposes, including drinking water, oxygen production, and even as a component for fuel. This means that future lunar bases could rely less on supplies from Earth, making long-term habitation more feasible. In summary, the discovery of water molecules on the moon's surface not only enhances our understanding of its geology, but also opens up new avenues for exploration and potential human settlement. As we continue to study these findings, the moon may become a vital stepping stone for humanity's journey into deeper space. Water plays a fascinating role in the interaction with lunar soil, known as regolith. This fine, powdery material covers the moon's surface and is composed of various minerals and glassy fragments. When water interacts with regolith, it can significantly affect its physical properties. For instance, the presence of water can alter the cohesion and friction of the soil, making it easier or more challenging to work with during construction or excavation activities. Understanding how water influences regolith is crucial for future lunar missions, especially when it comes to construction and resource extraction. If water can enhance the stability of regolith, it could be used as a building material for habitats or other structures on the moon. Conversely, if water weakens the soil, engineers will need to develop strategies to mitigate these effects. This knowledge will be vital for establishing sustainable lunar bases and ensuring the safety of astronauts. Several studies have analyzed the behavior of water in lunar conditions, including experiments conducted in vacuum chambers that simulate the moon's environment. These studies have shown that water can exist in various forms, from ice to vapor, and can interact with regolith in unique ways. Researchers are also investigating how water can be utilized in situ resource utilization, or ISRU processes, which aim to use local materials for construction and life support. In summary, the interaction between water and lunar regolith is a key factor in planning for future lunar exploration. By understanding these dynamics, we can better prepare for the challenges of living and working on the moon. Water is absolutely critical for sustaining a human presence on the moon, and its availability could determine the success of future missions. First and foremost, water is essential for drinking. Astronauts need a reliable source of hydration to maintain their health and performance during extended stays on the lunar surface. But water's role goes far beyond just drinking. It can also be used for agriculture. Growing food on the moon will be vital for long-term missions, and water will be necessary for cultivating crops, providing essential nutrients for astronauts. Moreover, water can be transformed into hydrogen and oxygen through electrolysis, making it a valuable resource for fuel. This means that lunar water could potentially power rockets for return trips to Earth or further missions into deep space. The ability to produce fuel on the moon would significantly reduce the costs and logistical challenges associated with transporting resources from Earth. The strategic importance of water for long-term lunar bases cannot be overstated. Establishing a sustainable human presence on the moon requires a self-sufficient ecosystem, and water is a cornerstone of that system. Upcoming missions such as NASA's Artemis program aim to explore and utilize lunar water resources. Artemis plans to land astronauts near the lunar South Pole, where water ice is abundant, and conduct experiments to assess its viability for future use. In summary, water is not just a resource, it is a lifeline for future lunar exploration. Its availability will play a pivotal role in shaping the future of human habitation on the moon and beyond. And as we look towards a future where humans can live and work on the moon, the role of lunar water becomes even more significant. Imagine a lunar base where astronauts can draw water directly from the moon itself, drastically reducing the need for supply missions from Earth. This water would be used not only for drinking, providing essential hydration for the crew, but also for growing food. With the right technology, lunar greenhouses could flourish, using water to cultivate crops that can sustain astronauts on long-term missions. Fresh fruits and vegetables grown on the moon would not only provide nutrition, but also boost morale and mental well-being. But the utility of lunar water doesn't stop there. Through the process of electrolysis, water can be split into hydrogen and oxygen. These elements are critical for creating rocket fuel. Picture this, a self-sustaining lunar base that can generate its own fuel for missions deeper into space or for returning to Earth. This capability would mark a significant leap in space exploration, making missions more cost-effective and feasible. The potential for lunar water to support a sustainable human presence on the moon is vast. It represents a cornerstone for the future of space exploration, paving the way for humanity's next giant leap, establishing a permanent foothold on another celestial body. In this video, we've uncovered some fascinating facts about water on the moon and its significance for future exploration. We started by discussing the presence of water ice in permanently shadowed craters like Shackleton Crater, which could serve as a vital resource for astronauts. We then explored the discovery of water molecules on the lunar surface, revealing that the moon is not as dry as once believed. Next, we examined how water interacts with lunar regolith, affecting its physical properties and implications for construction and resource extraction. Finally, we highlighted the critical role of water in sustaining human presence on the moon, emphasizing its importance for drinking, agriculture, and fuel production. The key takeaway is that water on the moon is not just a scientific curiosity, It is a crucial resource that could enable long-term human habitation and exploration. As missions like NASA's Artemis program aim to utilize these lunar water resources, the future of lunar exploration looks promising. If you enjoyed this journey into the mysteries of lunar water, we encourage you to subscribe to our channel for more exciting content on space exploration. Don't forget to like and share this video with fellow space enthusiasts, and check out our related videos to dive deeper into the wonders of the universe. Your support helps us continue to bring you the latest discoveries and insights from the world of space science. Thank you for watching, and we look forward to exploring more with you soon.